Welcome back, class, and we're going to continue with part 2 in this video lesson in this chapter of motion. Previously, we talked about distance and displacement, and these two words are often used when we talk about motion or the movement of objects. For this second part, we're going to talk about two more words that we use to describe motion or movement of an object, and those two are speed and velocity. So, what is speed and velocity? Speed is defined as the total distance covered per unit time, or otherwise known as the rate of change of distance. So it is how much distance covered in a certain period of time. If let's say you cover a lot of distance in a short unit of time, you are very fast. You have a high speed. But if you cover low distance over a long time, so that means you have a low speed. In other words, you are slow. Okay, so that's what speed is. How much distance you covered in a certain period of time. Now, speed is a scalar quantity. That means you don't have to think about this direction when you're talking about speed. Therefore, it only tells us how fast an object is moving, irrespective or not concerning with the direction. There is a formula to calculate speed, and this formula you have to remember. Speed has a symbol v is equal to distance, and the symbol for distance that we use in physics is s over time. T stands for time. Okay? When you have speed that is changing over time, so the speed is not the same over time, we use another formula to calculate the average speed, and this is basically just the same as the formula before. It is the total distance over total time. So let's do an example. A car travels from Jurdong to Gadong, but on the way to Gadong, the car stopped at a petrol station for 10 seconds. The distance between Jurdong to Gadong is 1 kilometers, and the distance from the petrol station to Gadong is 500 meters. The car took 400 seconds to travel from Jurdong to the petrol station, and 200 seconds from the petrol station to Gadong. What is the car's average speed? So, if you want to find the average speed, you have to use the formula that we mentioned just now. So, average speed is total distance over total time. The total distance is 1000 plus 500. So, that's how much this car has traveled. And what's the total time? You just add up all the time that the car takes in order to get to its destination, which is Gadong. Okay, so add those numbers up and then do your maths, and you will get 2.46 meters per second. And this is to three significant figure. So that's speed. It tells you how fast things are going. What about velocity? So velocity is a bit the same. Velocity also tells you how fast things are going. But velocity is a bit special because for velocity, you have to think about the direction. You have to include direction when you are talking about velocity. So basically, velocity is just speed with direction. Velocity is defined as the rate of change of displacement. So in other words, how fast the object is changing its position, or what is the change in position over time. Now, because you have to think about the direction when you think about velocity, velocity is a vector. The formula for velocity is this one here. V is the symbol for velocity. X is the symbol for displacement divided by the symbol for time, which is t. Both speed and velocity tells you how fast things are going, and therefore they both have the same unit, which is meters per second, which you can write like this, meters per second, or you can write down like this, meters second to the power of -1. So these two mean the same thing, but they are both written in different ways. Okay, let's do an example. Example 5 here is the same case as example 3 that we did from the first video lesson from part 1 of this topic. But this time we are asked to find speed and velocity. Now, if you remember from example 3 that we calculate, the distance is 420 meters and the displacement is 140 meters east. So these are the answers to example 3. We're going to use this to find the speed and velocity for this skier. So we want to find speed. What's the formula for speed? Speed is equal to distance over time. So we know the total distance the distance covered by this skier is 420 meters, and the time it takes to do all of that is 3 minutes. Okay, now because speed is in meters per second, so speed that we will calculate will be in meters per second, but when it comes to the time, we are given minutes. We have to convert minutes into second. Now we know 1 minute is equal to 60 seconds, so 3 minutes is basically 3 times 60. So you do cross multiplication here, 3 times 60, and that will be 180 seconds. Okay, so the time in this case is 180 seconds. So you calculate that, and you will get 2.33 meters per second, and this is to 3 significant figure. Okay, very important in physics. When you calculate and you get a long number, especially when it's in decimal places, you just round off that number to 3 significant figure. Next, we want to calculate velocity, and velocity is equal to the displacement over time. What is the skier's displacement? It is 140 meters east. And what about his time? He has the same time, which is 180 seconds. So the velocity of the skier is 0.778 meters per second east. And this is also to 3 significant figure. Okay, so that's the velocity. Now, because speed and velocity, they're almost the same, but they're slightly different, you need to understand what we mean when we say constant speed and constant velocity. So constant speed means that speed that is the same at all times. Let's say you are driving and you are driving at 50 kilometers per hour until you reach your destination. That means you are driving at constant speed. Your speed doesn't change. It just maintains at that speed. Okay, so that's what we mean by constant speed. So consider the following scenario. A car is moving around a circle while maintaining a speed of 15 meters per second throughout its motion. Since the speed of the car is unchanged, so this car is probably going around and around, like maybe in a roundabout. Because the speed of the car is unchanged, we say that it is moving with constant speed. So the speed doesn't change at all. It's the same speed, which is 15 meters per second at all times. So it's moving with constant speed, or you can also say another name for constant speed is uniform speed. Uniform and constant, these two mean the same thing. Okay, it means it's unchanging. However, when you think about this in terms of velocity, you have to ask yourself, is it moving in constant velocity? And here's the answer to that. It's quite long. Okay, let's read. I'm going to read it out. Even though the car is moving around in circles at a constant speed of 15 meters per second, we cannot say it has constant velocity. Because remember, velocity is a vector, and thus you have to think about its magnitude and its direction. In this case, its magnitude or the speed is the same, right? But the direction is always changing. So since the car is always changing its direction while moving in circles, therefore its velocity is changing. What do we mean by its direction is changing? So when the car is over here, its direction is pointing there. It's pointing upwards. When the car is here, the car is pointing there. When the car is going here, this is the car's direction. When the car is here, this is the car's direction. When the car is at here, at the bottom of the circle, that's the car's direction. So throughout this circular motion, the direction of the car is always changing. Okay, now because the direction is changing, therefore we cannot say it's moving at constant velocity. So speed is constant when speed is unchanged, when it has the same value over time. Velocity is only constant when both the speed and the direction is unchanged. Okay, for example, a car moving straight with a constant speed of 15 meters per second. Because the speed is constant, like I said, it's 15 meters per second at a constant rate. So its speed is constant in this case, and its direction is also constant because it's only moving straight. It's only moving in one direction. Its direction doesn't change. So in this case that I just gave you, this is an example where both velocity and speed is also constant. So to summarize this video lesson, make sure you understand the meaning of speed, which is written down here. Make sure you know speed is a scalar quantity. make sure you remember the formula for speed, and then make sure you remember the definition of velocity. You know that velocity is a vector, and you remember the formula for velocity. And also make sure you remember the unit for speed and velocity is meters per second, or you can also write it down this way. And lastly, make sure you understand the meaning of constant speed and constant direction. Constant speed means only the speed is unchanged, the value is the same. Constant velocity means that both speed and direction is the same. They're not changing. Then you will have constant velocity. In the next video lesson, we're going to talk about acceleration, which is another term that we use when we're describing motion or movement of an object.